Matt,
Yes, Jamie.
what's your favourite type of rings?
Is it Lord of the Rings?
I quite like a diamond ring.
No.
But Matt, do you know what's better than all of those?
Saturn's rings?
Yes!
The Interplanetary Podcast, the exploration of space for the benefit of all mankind. Your hosts, here in London, Matthew Russell and Jamie Franklin.
The Interplanetary Podcast. It's not rocket science. Not.
Have we got any listeners left after that? Matt, it's podcast 18, and I'm so excited because we're talking about Saturn's rings.
I know, this is... You've been wanting to do this one for a while, haven't you?
I've been wanting to do this for months, and we're finally here. Yes.
And it's a really pertinent one to do, I think, because one of the things that's really exciting this year is the conclusion of the Cassini mission.
Absolutely, yeah. I mean, I think it's only got how long left before they plunge it into Saturn?
Well, I think it's plunging down in September. So if they can do that on my birthday, that would be pretty cool.
Yeah, that would be cool. Good old Cassini. Thank you for your service.
It is one of the most amazing space programs of all time.
Agreed.
So many cool things. If you go on the NASA page and look on the Cassini timeline,
yeah.
Just the photos. If you're just into photos of amazing stuff, Cassini, I think, has taken more photos of amazing stuff than any other satellite or any other person ever. It's just ridiculous.
Agreed. Yeah,
so good.
It's absolutely stunning. And like we were talking about before we pressed record, when you don't really think much about what Saturn's rings are, it does blow your mind when you learn a bit more about it. We just want to blow a few minds today.
Yeah. Do you know what? One of the great things for researching for the podcast is that you learn so much. It's brilliant. I like it.
What a pair of learners.
Yeah, we're learning, and we're hopefully listener. Yeah, because it has dropped down to one.
Yeah,
you can join us on this journey of discovery.
Oh, I like that, Matt. That was very Sky at Night.
So there was a chap called Galileo that you may have heard of, or Galileo Galilei, who was pretty much the first person to kind of look through a telescope.
Yeah, he was.
And one of the first things he did with this telescope, other than look at the moon and describe that in great detail, was to look at Saturn. And this is what he said. Saturn is not a single star, but is a composite of three, which almost touch each other, never change or move relative to each other, and are arranged in a row along the zodiac, the middle one being 3 times larger than the lateral ones. Yeah, he thought it was a triple planet.
I think we can definitely forgive him because it was 1610.
Well, imagine how rubbish his telescope was. The funny thing is, I absolutely demand that everyone do this, is look at Jupiter and Saturn through binoculars, because it's incredible, because you can see their moons and things purely through binoculars. Find a place where you can sort of rest your binoculars so they're not wiggling around. But I wonder if through binoculars you can see Saturn's rings as a triple planet. It'd be interesting.
Yeah, that would be interesting. You can kind of feel like Galileo felt.
One of the greatest things in my life is the first time I saw Saturn through a telescope.
See, mine was Jupiter in your garden, Matt. That's the time that it blew my mind.
Yeah, I mean, Jupiter and Saturn. I just can't believe that you can see these things just literally floating out there in space. Yeah, they look like they're painted on.
It doesn't seem real, does it? It doesn't seam real. But you know what, Matt? It is real.
It is real. Well, this is the crazy thing. This thing is real.
It's actually real. So if we skip forward 45 years after that...
you get one of my favourite astronomers is Cassini-Huygens.
This guy.
When the Dutch ruled the world, this was in their little brief period where the Dutch were absolutely smashing it.
And he quite cleverly... through some help with his more powerful telescope, proposed that Saturn had a thin, flat ring. I mean, that's pretty amazing considering that it wasn't that. It wasn't much more forward in time. 45. I mean, this was still 1655.
Well, Cassini-Huygens, if you read about him, he did so many amazing things, including working out how bright stars are using this special method. Just read about Cassini-Huygens. He's incredible. And he had a friend, Giovanni Cassini, Now, we've just mentioned Cassini, but Cassini is obviously what Cassini, the spacecraft, is named after. And he went a little bit further than Huygens and could actually resolve the separation between the A and the B rings. So he's the first person to see that there was actually a sort of gap in between the rings.
It blows my mind that he could work stuff like that out. When you think about the distance involved in 1675.
Yeah, it's absolutely preposterous.
It's really insane.
And right now, guess how far Saturn is away from us?
I don't know. Hit me.
It's almost exactly 1 billion miles away. I mean, like, it's actually really weird. When I looked up where it is at the moment, yeah, it's almost exactly 1 billion miles away.
Matt, did you say that with your pinky next to your mouth?
1 billion miles away.
1 billion miles. Twice every almost 30 years, Saturn appears ringless.
Yeah.
When its rings are edge on as viewed from Earth.
Yeah, well, you imagine at a billion miles distance, you can't see, because Saturn's rings are only about 10 metres thick. So obviously you can't resolve 10 metres from 1 billion miles away, so it just disappears.
Yeah, absolutely. And actually, the closer you get, the more kind of discordant they are. There was some peaks that are as big as Mount Everest. Is that true?
I don't know. I always thought that it ranged from snowball size to the size of a house. But there's certainly the moons that travel in between the gaps.
Yeah,
which are creating the gaps. They become they're about the size of Mount Everest. Well, some of them
insane.
So I want to talk just quickly about the space missions that we've sent to Saturn to discover all this stuff, because the things that we've discovered are incredible.
Right, so who was up first?
So we haven't had many, and we'll go through all of them, because there haven't been many spacecraft that have made it out that far. The first one that got out that far was Pioneer 11, which was in 1979.
Year I was born. Go on, Pioneer.
So your life and Saturn's discovery are very much intertwined, James.
That's true.
So so Pioneer 11 was sent out as a kind of pioneering mission before they sent out the Voyagers, and it flew about 22,000 kilometres away from Saturn and discovered the planet's outer rings. So it actually discovered that there was 2 more rings that you couldn't see from Earth.
Right.
And also discovered that it had a ridiculously strong magnetic field.
Yeah, of course.
And next up, we had the Voyager, which confirmed the existence of an extra 9 moons. And then in October 1997, there was a Titan rocket launch that flew up the Cassini spacecraft, which you mentioned earlier. That went round Venus a couple of times to get an assist, and then went round the Earth and Moon after that for a quick assist again, through the asteroid belt where it did a bit of science, went past Jupiter in 2001 where it did a little bit more science as well, and then by the 1st of July 2004 began to orbit around Saturn. I remember that, and I can't believe that's 13 years ago.
Yeah, that's nuts.
And it's the largest interplanetary spacecraft ever built. So it's the size of a 2-storey building.
Wow. So
it's very similar to that one that we stood next to in the Science Museum in terms of size.
Yeah, that's pretty big.
So 6 tons.
6 tons in weight.
Yeah, so imagine it's the size of one of those American 30-passenger school buses. So that kind of yellow
pretty
bus.
Big, hurtling in space.
Yeah, it's massive. This thing's massive. We won't be able to cover all the discoveries that made in this podcast. I mean, we could devote a podcast to Cassini, because it discovered the plumes of ice on Enceladus. And it carried the ESA's Huygens probe. So it's nice that Cassini and Huygens both went out to Saturn.
Double up.
Yep, and Huygens probe, that was in the news recently because they released a video of it landing on Titan.
Yeah.
And Titan, by the way, is bigger than Mercury. So there was a video of that the other day at the surface, because it was January the 14th, 2005, so exactly 12 years ago, that landed on Titan, the first spacecraft to land down on a moon of another planet.
Yeah, that's insane. So Titan the is it the furthest moon away from Saturn?
Do you know what? I don't know, but that probably would be right, because it's certainly the largest.
I've got a feeling it is. Yeah,
and it's got methane lakes, which is something that Cassini discovered.
Cool.
Yeah, so it looks a bit like a sort of planet, but all the wrong colour.
I imagine that if hell was real,
yeah,
that it has methane lakes on it.
Ooh, yeah. Although there is a chance that life might exist in these methane lakes, which would be pretty exciting, wouldn't it?
That would be exciting.
So Cassini discovered a new ring in 2006.
Yeah.
That's related to the moons Janus and Epimetheus. One of the most exciting photos ever taken is the one where Cassini gets behind Saturn, and Saturn is blocking out the sun.
Yeah.
And so the whole of Saturn is brilliantly backlit, and it was able to see, like, just in incredible detail some of the sort of outer rings that hadn't been able to be seen before.
Absolutely.
And just how all these rings are split up. That is absolutely incredible.
Absolutely amazing. You should definitely check that photo out. So let's talk quickly about the rings. So we've got, I think, is it up to G ring? But from A to G?
Yeah, and that I believe the one that was found by the Spitzer Space Telescope.
I believe it was.
And that's got something to do with Phoebe, one of Saturn's furthest moons, is likely the source of the material for that ring.
Yeah.
So, yeah, that goes all the way out. So that, or is that the F ring? I can never remember.
Oh, it's tough. It's tough.
Yeah, so maybe if you know difference between F and G ring, you can write in. Let us know.
All you F ring fans, get in touch.
So yeah, one of the things that he also did, Cassini, is take that picture of Earth faintly to be seen within the rings of Saturn as it looks back towards us. So recreating the pale blue dot, as it were.
That's amazing, isn't it?
That's a 2013 image. That's definitely worth checking out.
Oh, if only Sagan was alive to see that.
I've come up with a song that helps me remember the order of the rings.
Oh, here we go. Get the guitar.
It goes D, C, B, A, B, A, F, G. And that helps me remember the order of the rings, Jamie.
That song is now available from iTunes and is downloadable as a ringtone.
Thank you very much. It's pretty good, though, isn't it? It's nice.
It's really good. Really catchy.
Nice way of remembering. And so that's the order of the rings from Saturn out.
Nice.
Obviously, the D ring was discovered quite late because it's very, very, very faint indeed.
So, Matt, if you retraced the 3.2 billion kilometres that Cassini's travelled to reach Saturn in a car at, let's say, 62 miles an hour, how long would that ride last you?
Oh, I'd go at about 3,653 years.
That's ridiculous. But thankfully, Cassini was travelling a little bit faster and did it in about 7 years.
Oh, so in April, Cassini will dive through the gap between Saturn and its innermost D ring at nearly 76,000 miles per hour relative to Saturn's centre.
So here's a question: so it'll break up and some of it will burn away, but will parts of it just live inside one of the ring's orbits forever?
No, it's going to burn up in Saturn's atmosphere. They're absolutely, one of the things is to make sure that the Cassini spacecraft is completely destroyed, because they don't want to contaminate the rings at all.
Yeah, because if space junk starts, crashing into moons and stuff, then it could cause all kinds of palaver.
Well, yeah, one of the really beautiful things about Saturn's rings, if you imagine it as snowballs and ice, they're continually bashing into each other. I mean, this is basically really rings that stretch out for 320,000 miles or whatever it is, but it's only the thickness of snowballs. Maybe some of them are 10 meters, like a sort of, like an iceberg or something.
Yeah.
But they're mostly snowballs, and these snowballs are continually smashing into each other.
And that's why they stay bright to
and
our
they stay
image.
bright, yeah. They stay bright because they're continually kind of hitting each other and kind of almost like fresh, icy snow.
I love that.
Yeah, well, it's just beautiful, isn't it?
That is so cool.
It's interesting to note that, do you know what? I can't believe it. I keep having to remind myself about this. Saturn shares the same name as the day that we're recording this podcast, of course.
What?
But because Saturday and Saturn get from the same derivation, and because Saturn is the 6th planet from the Sun, and Saturday is the 6th day of the week.
No way.
Yeah.
Matt, I've learned another new thing today. I can't believe it.
And here's another really good thing. And even though it would contain 760 Earths, it's only got 1.1 times the gravity. So if you could jump 10 foot on Earth, you'd be able to jump about 9.4 feet on Saturn. So it barely makes no difference at all.
That is cool.
And one of the reasons is because Saturn is so undense. It's in fact so much so that if you could get it into a lake, it would float. So Saturn would float in water.
My God, that's ridiculous.
Yep. And so far we've discovered confirmed 53 moons, and there's another 9 that are on the provisional list. So it looks like there's at least 62 moons.
Now, that is a lot of moons.
What's your favourite moon? Because I know what mine is.
Well, I'm going to go with Titan. Just because I like the name.
Yeah, and it is huge, and it's so interesting. But mine is, and I think a lot of listeners out there, is Mimas. Because it looks exactly like the Death Star. Because it's the one with that massive crater in it, and it makes it look like the Death Star. And that crater, by the way, is the same size as the United States.
Yeah, that's a big crater.
Yes, it's a big crater. But that gives you an idea of how big Mimas is. Even though it's one of the sort of smaller moons, it's still a substantial body out there.
Which is quite ironic, Matt, actually, because somebody put up on the internet a very funny video this morning of Donald Trump walking out to be made president, and they put it to the theme tune of the Imperial March by Star Wars. So. It's really good. Check it out.
The Cassini division is in between the A and the B ring, by the way. So as we go out, so that's what Cassini could see, and it's the sort of largest of all the gaps, and that's obviously caused by one of the moons that's basically sucking up all the material. But what's a really, really exciting image that came through really very recently, because on November the 30th, 2016, Cassini decided that it was going to start its new phase of missions, which was actually ring grazing. So for a while, it's going to be sort of, as it whizzes round in its massive elliptical orbit, much like the kind of orbit that Juno's doing, it's going to whiz by the rings and get very, very close to those outer rings before this April one, where it starts to dive in between the planet and the rings. Yeah. So these orbits are incredibly, they're running out of fuel, and they think, well, let's just get some really amazing science before the end of the mission. So it's absolutely incredible what they're doing. So this one, they've taken some incredible images they've gone through. So we've just got one from a couple of weeks ago in January. Yeah. Where it's dipped through the ring plane and has taken an amazing image of Daphnis, which is one of those moons that's about the same size of Everest. And Daphnis is the brilliance of this photo is the fact that Daphnis is sitting there in its own little band that it's caused. Yeah, and the rings themselves ripple around it, so you can see a ripple in the waves.
It does look amazing, and the actual shape of the moon itself.
Oh yeah, the whole thing. It's one of the most stunning images you'll ever see, and it's by far the highest resolution of Daphnis itself. Yeah. But it's interesting, the science that causes this. So just the moons, unlike the rings, aren't necessarily orbiting at exactly the same plane, or aren't necessarily orbiting exactly in a circle. They're actually slightly elliptical. So Daphnis has a slightly elliptical orbit. So it kind of sort of almost nudges into the rings and nudges back as it goes around. So that it causes this ripple in one dimension. But not only that, it's slightly tilted in its orbit as well. So it causes a ripple in another dimension. Not in another dimension, as in a sci-fi dimension, but in another spatial dimension.
I was about to get really excited.
Yeah,
so that's a whole other podcast.
Yeah, so it's causing ripples left to right and right to left. And what's brilliant about Cassini as well, it's able to sort of take images so that the sun is grazing across the top of the rings, and so every now and then, since it's been orbiting, it's had the fortunate position of being able to get very large shadows of this up and down movement within the rings, so that you can see the shadow cast across the rings as the sun shines across, almost edge on to the rings. And so you get some fantastic imagery at those times.
Yeah,
it's
that's
so
ridiculous.
Cool. That's an image. It's one of my favourite images, and that was taken really very, very recently in
check it out. All of this is going to be on the blog, by the way, peeps. So check it out.
Another brilliant image that they did with Cassini is Cassini to go the other side of Saturn.
Yeah,
and send lots of radio waves through the rings, and then Earth pick those radio waves up. And they were able, and that way they can sort of look at the density and on all those sort of things of the rings as you go through, as you go through, and that image of the radio occultation, as they called it, is another one of those just fantastic images of Saturn, because you can really see clearly the ring structure in a completely different way. It's fantastic.
I'm looking at it now. It's absolutely stunning. Definitely check out the Tumblr.
Oh no, the mass spectrometer aboard the Cassini probe was used to analyse the age of Saturn's rings. So the rings were not formed at the same time, and the oldest ones are nearer the planet. So you can...
Yeah, that I guess in sense of, I don't know if we've even talked about how the rings got there in the first place yet, but it's believed to be pieces of comets, asteroids, shattered moons that broke up before they reached the planet. So I guess that would make sense in terms of, the first things that were hitting the planet were going to form that first orbit. But it doesn't really make sense other than that, does it?
No, it's with something as massive as Saturn. All the outer gaseous planets have rings, but Saturn's is the only one that you can really see with the naked eye. Particularly from...
I was going to say, Matt,
Earth.
Yeah, a lot of people don't think about it, but even Uranus has rings.
It's something I've certainly never thought about. The rings... I guess when something's massive, like one of the gas giants, it rips apart anything that comes anywhere near it. Yeah. And then these things can never form into moons because the gravitational pull is just so enormous.
It's just too strong, yeah.
You get these gravity resonances throughout the ring system. That means that you get these little moons forming. And that's something that I wanted to talk about, actually, is that you can perceive Saturn's ring system as a mini version of the solar system itself. So if you replace Saturn with the sun, and then all these moons as the big moons as the planets, and then these little tiny moons as things like the asteroid belts, or even maybe the rings themselves as the asteroid belts and the Kuiper belts and things like that. It actually... Studying Saturn's rings gives you a really, really deep insight into how the solar system formed. So it's interesting on many, many levels. Not only is it one of the most... you could argue it's the most beautiful thing in the solar system.
I think so, personally. That's why I was excited to do this, because it's just... It's the poster boy of the Milky Way, isn't it?
Yeah, there we go. It's the poster boy of the Milky Way. Yeah. It's fantastic, yeah.
Or girl.
Or girl. I'm going to go with girl. There's something quite feminine about it.
Yeah.
Yeah, man. So there's 7 rings, and I gave you my little song, didn't I?
Saturn. Sorry.
Is Saturn white? No, Saturn isn't white, Jamie. It appears slightly yellow.
Well, do you know what? The irony of that, Matt, is that's the opposite of the sun. Because the sun, everyone thinks, is yellow. It's actually white.
That's absolutely right.
Yeah.
And do you know why it's white?
No.
Because we've grown up as a species, as everything under the sun. So our eyes are adapted so that the sunlight is even, so we perceive it as white. But if we'd grown up near another star, maybe that would appear white. See what I'm saying?
I do.
So
see
it's
what
not the
you're
fact that
saying.
it's white; it's just the fact that it's white to human vision,
It's
because
white
that's
to
what
us. Yeah.
Exactly. Yeah.
So are you saying, Matt, that if you were somebody looking at me from Saturn, I could have a bright blue face?
Yes.
I quite like that.
Yeah, that actually, yeah, you probably would. That's quite good. That's quite clever.
Yeah.
Enceladus is responsible for creating the E-ring. That's one of my favourites. Enceladus. We keep getting really, really good pictures of these geysers of water coming from the surface, and that's obviously Saturn's pull is pulling the innards of Enceladus so much that it's heating up, and it's a watery body, and this water is spraying out into space, and this ice fountain is causing the E-ring. So the E-ring is made up of pretty much Enceladus's insides.
Oh, that sounds painful.
And one thing that was discovered by the Voyager missions, and then Cassini's had some fantastic shots of it as well, is the spokes that appear across the rings. These weird kind of, they look like spokes of a wheel. So as it goes round, they come and go across the surface of the rings out, and it's pretty much a mystery. Although one of the best explanations for the spokes is by Professor Caroline Porco.
Oh yeah.
And she's conjectured that the spokes might be composed of electrically charged sheets of dust created by either small meteors impacting the rings, or it could be electron beams coming out the back of the planet's lightning.
Whoa.
So these spokes might be caused by the lightning on Saturn's surface, which is extremely exciting.
Matt, when you were a kid, did you ever have? Were you ever one of the kids to have like those things that you put on your bike spokes that made really annoying noises?
Spokies.
Oh right, is that what they were called?
I think they're called spokies. Yeah.
Really?
Yeah. Well,
yeah. I never rocked one of them, but my neighbour always had one, and you could hear them coming.
No, I never had them. I never saw the point of any of that. Bike furniture, as I used to call it.
Yeah, big time.
How fast is Saturn travelling compared to us? Or relative to us, I should say.
I mean, I'm going to estimate. I mean, I'm going to say it around 21.5 thousand miles an hour.
Wow.
How close am I?
Jamie, you're pretty close.
Really?
Yeah, I'm going to say that's bang on.
It's almost like I found the information and then I read it.
Did you read it on Reddit?
I didn't, but I should have done.
Saturn rotates in the same direction as Earth.
West to east.
So, Jamie, let's talk about what happened in the news.
I want to start, Matt, with Falcon 9.
Yes, obviously.
Of course we want to start with Falcon 9. I mean, wow, not a shoddy return, was it?
No, do you know what? I Chromecast the live feed onto my big telly and watched it with the kids. And I have to say, it's one of the most exciting things I've seen, because there was so much riding on it. Like we discussed, I mean, SpaceX really can't afford to put many feet wrong this year.
No, they had to nail this, and they absolutely did nail it.
It was a totally successful launch of the 10 Iridium Next satellites. Got them all into orbit, all in the right position. Job done. Bang. But one of the craziest bit was the return of the booster, landing on the barge.
I love that the barge was called Just Read the Instructions.
Yeah.
Imagine, see, that's really, you've got to be confident to name it that. Because imagine if it goes wrong and you've called it that.
Not only did it landed absolutely smack bang on the X. The photos are the best I've seen. The photos of that landing are really, really, really good. But the live transmission pretty much remained all the way down, and you saw the whole thing. It wasn't one of those ones that cut out because of all the vibrations. Yeah. So it was incredibly, incredibly exciting. And everything worked absolutely perfectly. So well done, SpaceX.
Well done,
Very
SpaceX.
exciting.
Good to have you back.
There's a SpaceX launch coming up again soon as well. We'll get onto that when we get onto the launches.
Matt, do you want a bit of history?
Go on then.
345 years ago, Isaac Newton revealed his reflector telescope and was elected fellow of the Royal Society.
And I have a Newtonian reflector telescope, as I believe you do as well.
That's so right.
Most telescopes are really based on that Newtonian reflecting thing. So rather than having, like Galileo had, a glass lens that bends the light, you have mirrors that bend the light instead. One large mirror that then shines the image up to a smaller mirror that then shines that image into your eye. And and Isaac Newton, amongst other ridiculous things, invented the reflector telescope 345 years ago.
Good work, Isaac. What a legend.
This month, we should mention. OSIRIS-REx, that did a deep space manoeuvre on December the 28th. Nice. And that's been confirmed to have worked, so that's pretty awesome. So it's continuing its 2-year journey to asteroid Bennu.
Very good.
One thing all you listeners can do that's really, really exciting, just like the Cassini mission, we have the Juno cam aboard Juno, which is basically the sort of Jupiter equivalent of Cassini. You can actually vote for the part of Jupiter that you want imaging.
Yeah. So
the Juno cam has been literally put on there.
They've done one already, haven't they? Or have they done more than one already?
Yeah, no, they've done one already, and the
yeah. I saw one online. I mean, amazing.
Yeah, so for this flyby, the voting is open from January the 19th to January the 23rd. So quick.
What are you going to vote for, Matt?
Get your vote in. Oh, I don't know. I haven't looked.
What do you want to see?
I'm not going to vote for the red spot because that's been done.
So obvious.
Red spot. The GRS, as astronomers like to call it.
Yeah.
Oh, and we talked about the Galileo. Satellites.
Yeah.
Named after Galileo, the first person to see Saturn.
Yeah.
Well, Saturn's rings, anyway. They've got some problems. The Galileo atomic clocks have all started failing.
Oh, God.
Now, each craft have got 4 atomic clocks, two different types, one main one and one backup of each type.
Right.
So it's not a disaster, but it's not great either.
No.
So there's obviously a design fault in one of the types of atomic clock that's on board the Galileo satellites.
Uh-huh.
So that might delay the launch of the next batch of Galileo satellites.
Ouch. Maybe they'll sort it out.
Well, I mean, they'll sort it out for the ones that they're launching. I mean, that's what they're going to do. So what's very depressing is the moment that Donald Trump got into office yesterday, any reference to global warming was removed from the government, from the American government website. And this is at a time where the NASA, the Goddard Institute of Space Studies, and the National Oceanic and Atmospheric Agency, NOAA, said that 2016 was the warmest year since modern record keeping began. And as an isolated thing, it might not be that worrying, but 16 of the 17 warmest years on record have occurred since 2001.
Yeah.
That's very, very scary, and the fact that I am deeply depressed by the anti-science administration that's so far revealing itself in the
it's
White
a scary
House.
it's a scary time, and you just hope that people can be able to change the government's opinion of that, because we already know what a few of them, including Donald Trump, think.
Yeah, and I think actually it falls down to people like the listeners of this show, us, other kind of science advocacy programs, and institutions like the British Interplanetary Society and people like that we are always putting pressure on governments and institutions around the world to make sure that the message of science is there.
Absolutely, absolutely. We can't keep calm about this. It's something that we have to put pressure on them about.
Oh well. There's a really cool space sound effects short film competition.
Go on.
That I thought that I thought was really, really cool on SoundCloud. It's launched by Queen Mary University in London,
right?
And it's designed to encourage filmmakers to use the weird and wonderful ultra low frequency analogues of sound waves present in the near Earth space environment.
Cool.
When you go on the SoundCloud section or on their YouTube channel, you can actually listen to all these different sounds from these different bodies, and one of them Saturn's rings, and I'll play that at some point when we're talking about it, so that you can hear what Saturn's rings sound like.
So where have they got these sounds from, Matt?
So what happens is that they take a piece of information like the radio waves coming off the planet, or some other information that has been captured by Cassini or something, or one of our other space probes, and then convert that into sound waves so that you can hear it as a sound rather than as plotted as a graph or plotted in a spreadsheet. And it gives you another perspective on that particular thing.
Well, I like the thought that maybe the next Radiohead single will start off with the, low frequency of Saturn's rings.
Do you know what? I'm absolutely certain that at some point Radiohead have used low frequency space sounds.
They've probably already done it. Yeah.
They must have done it already. I'm convinced. But anyway, so it's worth entering because
definitely
there's a potential £2,000 prize in it. Now we really the last bit of the news that I really wanted to go through was the sad passing away of Eugene Andrew Gene Cernan.
Absolutely, one absolute legend.
Yeah, I mean he's only been to the moon twice.
Oh, boring. Done that. Let's go again.
Done it. And he's also the last man to have stepped on the moon.
Yeah.
So he was,
Incredible.
the 11th man on the moon, and then as he was the last to leave it. So he's the last person to have been on the moon. He drove the lunar rover around, and at some point managed to get it up to 11.2 miles an hour, and so therefore He's the official lunar land speed record holder. He's
the fastest man on the moon.
He's the fastest man on the moon, the last man on the moon. He's been to the moon twice. I think he's the only one that went twice. And he also wrote his daughter's initials into the surface of the moon as he left, which I think is beautiful. And you should definitely go and see the film, The Last Man on the Moon, that came out a couple of years ago.
Oh, I haven't seen it yet. I'll have to check it out.
Oh, it's brilliant. It's by Mark Craig, a British filmmaker, and it's really, really, really good. Took 9 years to make, and it's basically based on Cernan's own memoirs. So it's fantastic. But
check that out.
Yeah, we're starting to lose all our Apollo astronauts, and so
they're going, aren't they?
So I think it's round about now that we really need to find a whole new set of Apollo astronauts that go to the moon and to Mars, hopefully.
Absolutely.
So at the end of this programme, I am going to play the sound file of Gene Cernan leaving the lunar surface, because it's a beautiful little speech, and he cleverly names the mission during it. So if you're a really, really cool listener, you can try and listen to what two words he puts together that relates to that Apollo 17 mission.
Let's talk about some launches. What's going on?
Last night we had a successful Atlas V launch of a military satellite.
Nice.
Obviously it's successful because it was an Atlas V.
Yeah, of course. Standard.
We've got a Japanese launch coming up soon. Again, this is for a Japanese military satellite.
Oh, what, the DSN-2?
Yeah, the DSN-2 military communications
Glory.
satellite. So that's a joint venture between Sky Perfect, JSAT, NEC Corp and NTT. So that's X-band communications for Japanese military units.
Nice.
Then on January the 26th, we had another Atlas V in the same configuration as the one that flew yesterday, a 401. Another military satellite for the National Reconnaissance Office, an NROL 79. And then, on the same day, we have another Falcon 9 launch.
Awesome.
Which will be the EchoStar 23.
Yes.
Which is a geostationary communication
satellite. Come on,
satellite.
SpaceX, you're on a roll. Don't stop now.
Right, Jamie, I think...
Yes, Matt?
I think we should say goodbye to our listeners.
Oh, goodbye, listeners. Thanks, as always.
Thanks very much for joining us again on this podcast. And thanks very much for supporting the show. And if you can all keep subscribing on iTunes and Stitcher and leaving us nice reviews and questions.
We love that.
And we've got some interviews coming up. I think the next 3 shows will have interviews lined up for. So definitely tune in next week, because we've got an awesome interview, and then we've got another awesome interview the week after. So definitely tune into the next two.
Do you know what, Matt? I'm going to say that anyone who posts a question up is going to get an interplanetary podcast pen.
Yes, that's a good one.
Matt, we need to get some interplanetary podcast pens made. But we will. I stand by that. All right, guys. Well, look after yourself, and we'll see you next week.
See you next week. Bye-bye.
Bye.
Bob, this is Gene, and I'm on the surface. And as I take man's last step from the surface, back home for some time to come, but we believe not too long into the future, I'd like to just let what I believe history will record, that America's challenge of today has forged man's destiny of tomorrow. And as we leave the moon in Taurus literal, we leave as we came, and God willing, as we shall return, with peace and in hope for all mankind. Godspeed, the crew of Apollo 17.